Now we will discuss some understanding based question which will help develop a better understanding of the concepts of chemical equation. Fine. So let's start. So the first question of this section is calculate the molecular masses of the following. Already you have worked on such type of questions. Again we will do some more for practicing. Calcium phosphate. So let us calculate the molecular mass of calcium phosphate. So what we are supposed to do for calculating the molecular mass? Yes, correct. First you have to write the molecular formula of calcium phosphate. So what is the molecular formula of the calcium phosphate? You must know by this time. So let us write that first. So it is calcium plus 2 phosphate radical is PO4 minus 3. So these are the constituent ions of calcium phosphate. So what is the formula of calcium phosphate? Crisscross method, Ca3PO4 taken twice, right? Now for calculating the molecular mass we need to know the atomic mass of individual constituents. So let us write that. Calcium is 40. Then which other elements are there? Phosphorus. Phosphorus is 31. Oxygen is 16. Fine. Now we will calculate. So remember that how many number of atoms are there in one molecule of that substance. You have to carefully calculate that part. Like calcium, how many atoms are there? 3. So 40 into 3 plus phosphorus, how many atoms are there? PO4 taken twice. That means 2. So phosphorus is 31 into 2. Fine. Plus oxygen, how many are there? So in one phosphate radical there are 4 oxygen atoms. Like that 2 radicals are there in one molecule of calcium phosphate. So total number of oxygen atoms 4 into 2, that is 8, right? So 16 into 8. Now you calculate and then find out what is the answer. Okay. So after calculation you check the answer. So let us see the solution. Okay. So the molecular mass of calcium phosphate is Ca3PO4 taken twice. This is 40 into 3 plus 31 into 2 plus 16 into 8 is equal to 310. Fine. I hope you have already done this problem. Okay. Now let us move on to the next question. We are continuing the calculation of molecular mass. Higher oxides of copper. So let's see. Copper and iron both you have to do. So we have to first, what you have to do? You must know about it now. You have to write the formula. Higher oxide of copper is what? Already discussed in the previous exercise. Cu plus 2. So Cu plus 2 O minus 2. What is the formula? CuO. Okay. Now very easy to calculate the molecular mass. Atomic mass of copper is 63.5. Oxygen is 16. Okay. Now you will calculate. It's very simple. 63.5 plus 16. Iron. Higher oxide of iron. Iron can exhibit 2 valencies plus 2 and Fe plus 3. Higher oxide means you have to consider the higher valency. So the compound is Fe plus 3. Compound will be formed between Fe plus 3 and O minus 2. So what will be the formula? Crisscross method, Fe2O3. How will you calculate the molecular mass? You have to know the atomic masses of iron and copper. Let us write. Iron is 56, oxygen is 16, right? I think you will be able to do. How many iron atoms are there? 2. So 56 into 2 plus how many oxygen atoms are there? 3. So 16 into 3. So 56 into 2 plus 16 into 3. Okay. Then you can find out the molecular mass. So let's check the solution. Solution is higher oxide of copper is CuO and its molecular mass is 63.5 plus 16, that is 79.5, and higher oxide of iron is Fe2O3, its molecular mass is 160. I hope you could learn this one, how to calculate the molecular mass. You can do any substance is given. What are you going to do? First, you are finding out that what is the constituent radicals, positive and negative radicals present in them. Write that first. Write the molecular formula correctly. Then you have to know the atomic mass of individual constituent elements. Then you calculate the molecular mass, right? Okay. Let's move on to the next question. The atomic mass of an element is x AMU and its atomicity is Y. What is its molecular mass? Very simple. You know the relation between atomic mass and atomicity and molecular mass. So what is atomicity? Let us already have studied, but still let us once again recapitulate. Atomicity is the number of atoms present in one molecule of the element. Fine. So atomic mass of the element is x AMU. So x AMU is nothing but the atomic mass. Now what is given? Its atomicity is Y. That means in one molecule of the substance, one molecule of the element, how many atoms are there? Y atoms are there. So atomicity is Y. So what will be its molecular mass? For mass of one atom is x AMU. Mass of Y atoms is what? X into Y. So this is into sign. So we can write it XY. Okay. XY AMU is nothing but the molecular mass of the element. Molecular mass of the element. Let's check the solution. Solution is molecular mass of the element is X into Y is equal to XY AMU. Fine. So let's move on to the next question. Next question is determine the coefficient of HCl when it reacts with one molecule of K2Cr2O7. What is K2Cr2O7? What is the name of this compound? This compound is constituted of potassium ion and Cr2O7 minus 2, that is dichromate ion. So potassium ion and dichromate ion. So the name of the compound is potassium dichromate. So what are the products obtained? Two metallic chlorides, chlorine gas and water are obtained in this reaction. Okay, so what we will do? We have to determine the coefficient of HCl. That means what we have to do? First we have to balance the chemical equation. Okay, so let's see. First we will write. So when K2Cr2O7 reacts with K2Cr2O7 reacts with HCl. What is HCl? Hydrochloric acid. Okay, two metallic chlorides. What should be the two metallic chlorides? You can see that potassium is there, chromium is there. Two metals are there, so two metallic chlorides will get. So potassium forms KCl, chromium forms, this C is capital, okay. Chromium forms, what is the valency of chromium? Its usual valency, it has variable valency, but generally it forms a stable compound in its +3 valency state. Okay, so chloride is -1. So the formula of chromium chloride is CrCl3, right? Other than that, what are the other products? Chlorine and water. Okay, now we'll balance it. So you can see that in the left hand side, okay, first I will tell you some rules for balancing the equation. If such kind of equation is there where you can find that one single element occurring in different substances. I'm giving you an example. Suppose potassium, if you look at potassium is there in left hand side in one compound, that is potassium dichromate, and right hand side in potassium chloride, 1 frequency. Okay, chromium is also like that in potassium dichromate and chromium chloride. Sorry, it is Cl2. Okay, now if you look at hydrogen also in one place in the reactant side and product side also in one place. If you look at oxygen in one place in potassium dichromate and in water in the product side. Okay, one place. But you look at chlorine in the reactant side in one place, but you see in the product side it is there in potassium chloride, potassium chloride, it is there in chromium chloride, it is also liberated in the form of chlorine gas. Fine. So 3 different products have this chlorine. So its frequency of occurrence is more than any other elements in this reaction. Okay. So in this case, I'll tell you the rule. The rule is you will balance chlorine at the end. Okay. Now, which one has less number of occurrences? Suppose potassium, chromium, oxygen, hydrogen, only in one compound in the right hand side and only in one compound in the left hand side. So that means their frequency of occurrence is same and it's less, minimum. Okay, so we'll balance first these elements. In these elements also, if you see, potassium and chromium are metal, oxygen and hydrogen are non-metal. Generally, we start our balancing from the metallic atoms. Okay, so let's start. So I will just change the color of the pen so that you can understand it in better way. See, potassium, how many potassium is there in the left hand side? 2 potassium atoms are there in potassium dichromate, and in the right hand side 1. So obviously I have to make it 2. Fine. Now look at chromium. 2 chromium atoms are there. Here in the product side only 1 chromium atom. So I have to make it, invariably I have to make it 2 here. So potassium and chromium, the metallic atoms, are balanced. Now you look at oxygen. See, oxygen is 7 atoms are there here. Okay. In the left hand side, in the reactant side. In the product side it is only 1. So invariably I have to make it 7. So let us write 7. The moment I am writing 7 here, what is happening? The number of hydrogens in the product side is also changing because it is water, H2O. So in the product side, how many hydrogens are there now? In 1 molecule of water, there are 2 hydrogen atoms. So in 7 molecules of water, how many hydrogen atoms are there? 7 into 2, 14. So here we have to write, in place of HCl, we will write 14 HCl, right? Okay. Now, potassium is balanced, chromium is balanced, hydrogen is balanced, and oxygen is also balanced. So which is not balanced? Only chlorine is not balanced. So let us balance now chlorine. Now left hand side you see 14 chlorine atoms are there. Right hand side also you have to make 14 chlorine atom. So from potassium chloride to potassium chloride, how many chlorine atoms do you get? 2. From 2 molecules of chromium chloride, how many chlorine atoms do we get? In 1 chromium chloride, there are 3 chlorine atoms. In 2 molecules of chromium chloride, how many chlorine atoms are there? It is 3 through 6. So total how many? 2 plus 6, 8. Okay. So still we have to have 6 more chlorine atoms. But here anyway, in 1 molecule of chlorine, there are 2 chlorine atoms. Now I will increase the number of chlorine molecules here in this case. Why? Because if I increase here or here in potassium chloride and chromium chloride, then other 2 elements, potassium and chromium, their numbers will also be disturbed. So I will not touch them. So since chlorine is there in the elemental state, I will change the number here. Okay. So 2 plus 6, 8. How many more we have to have? 6 more. So let us write here. So 3 2s are 6 plus 6 12 plus 2 14. Now left hand side and right hand side are same. Okay, understood? So now look at the question. Determine the coefficient of HCl when it reacts with 1 molecule of potassium dichromate, 2 metallic chlorides, chlorine gas and water are obtained in this reaction. So here you can see the coefficient of potassium dichromate. I didn't write anything, means it is 1. So 1 molecule of potassium dichromate reacts with 14 molecules of HCl. Fine. So your answer is 14. Fine. So let's look at the solution. So the coefficient of HCl is 14. I hope you could understand the balancing equation. You have done with me, no? Yes, very good. Okay, we'll move on to the next question. Next question is, if a magnesium ribbon undergoes combustion, it gains weight. Does this phenomena violate the law of conservation of mass? Okay. So first I will just give you a simple example. During Diwali or any festival, when you burst cracker, you can see that that magnesium ribbon we burn. it forms a white dazzling flame. We enjoy it, right? So this magnesium ribbon, if you burn, after burning you can find that there is a certain amount of gas, certain amount of white colored solid is formed. So if you check the mass of the magnesium ribbon and the white colored mass, you can find that the white colored mass, that mass is more than the mass of the magnesium ribbon. Why does it happen? So let us see. I think you already understood this and you know also about it, but still let us discuss. In this case, during the burning of magnesium ribbon, what is happening? Magnesium is reacting with oxygen to form magnesium oxide. So first we will balance the reaction. So here you can see one magnesium, here also one magnesium atom, but oxygen is 2 here, oxygen is 1 here, so I have to place a 2 here. Now magnesium is also disturbed. Here magnesium 2 atoms are there, so here we have to put 2, right? So first you had only magnesium ribbon, that is the magnesium. Now it is reacting with atmospheric oxygen to form magnesium oxide, right? So does it violate the law of conservation of mass? Definitely not. First we have taken the mass of, we have observed the mass of magnesium, then we have observed the mass of magnesium oxide. But the atmospheric oxygen we are not considering when we are considering the mass of magnesium. So this magnesium is combining with a gas, atmospheric oxygen, to form magnesium oxide. So if you carry out this burning of magnesium ribbon or any pieces of magnesium in a closed container, then you will find there is no change in the mass. Fine? Okay, good. So let us see the solution and then we'll move on to the next question. Magnesium on burning combines with oxygen and forms magnesium oxide. So it is not at all violating law of conservation of mass. Hence it gains weight. It does not violate the law of conservation of mass because the balanced chemical reaction is this. Okay. Oxygen gets added to magnesium. Calculate the equivalent mass of sodium and aluminum. So the relation between equivalent mass and atomic mass and valency, right? So what is equivalent mass? Equivalent mass is equal to atomic mass divided by valency. Okay. So first we will do for sodium. Sodium EQ, that means equivalent mass, is equal to, what is the atomic mass of sodium? Atomic mass of sodium is 23 AMU divided by valency. What is the valency of sodium? You must know. Many a times you have worked out on sodium ions. So its valency is 1. So equivalent mass is 23 AMU or U. Fine. If I say gram equivalent mass, then you have to write gram. Now we will calculate the equivalent mass of aluminium. So Al, its equivalent mass is equal to, atomic mass of aluminium is how much? You must know about it. So it is 27. What is the valency of aluminium? Aluminium valency is 3. So it is 9 AMU or U. Fine? Understood? Okay. Worked out? I think before me you are done with this problem, right? Okay. So we will move on to the next. First we will see the solution and then we will move on to the next question. Solution. Equivalent mass of sodium is equal to atomic mass by valency. So it is 23, and equivalent mass of aluminium, atomic mass by valency, is equal to 27 by 3 is equal to 9. Done. Next question. Let us see. What is the atomic mass of a trivalent atom X if its equivalent mass is Y? So what are the information we require to have and what are the informations are given in the problem? So understanding that is your first priority. So we have to again write the relation between atomic mass and equivalent mass. I hope you are ready with your equation, the expression, you know, okay? Equivalent mass is equal to atomic mass divided by valency. Now see what all are there. Trivalent metal atom means what is the valency? Here the valency is 3. Okay. what is the atomic mass of a trivalent metal atom X? The metal atom is X. If its equivalent mass is Y, its equivalent mass is given. So what is the equivalent mass? It is Y. So Y equivalent mass is equal to atomic mass divided by valency is atomic mass divided by 3. I know everybody is done with the answer. So atomic mass is equal to 3Y. Very good. So let's see the solution. The solution is atomic mass is equivalent mass into the valency. So it is 3Y, right? So we'll move on to the next question. Unit should be AMU or U. Atomic mass unit or unified mass. So what is the next question? Next question is, which gas is released during the formation of glucose from carbon dioxide and water? You must know about it. I need not say this reaction is representing formation of glucose means photosynthesis reaction. So photosynthesis reaction, what happens? Carbon dioxide combines with water in presence of chlorophyll and sunlight. Note it down, in presence of chlorophyll and sunlight, they form glucose. What is the formula of glucose? C6H12O6 plus oxygen gas. So which gas is released? Oxygen gas. Balancing is not asked, but let us have a practice of balancing. Carbon, 6 atoms are there in the right hand side, so left hand side also you have to write 6 here. Okay. Hydrogen, you can see that 12 are there, so here 2 are there in the left hand side, so you have to equate it, so we have to write 6 over here. Okay. Now oxygen. Let us see that oxygen is a frequency is more. You can see that oxygen is present in left hand side in the reactant, 2 substances, in the right hand side also 2 products it is present. So 2 reactants and 2 products, all of them they contain oxygen. So now oxygen we will balance at the end. Now you see the left hand side, how many oxygen atoms are there? 6 2s are 12 from carbon dioxide and 6 from water. So total is 18. Left hand side you look at, in glucose 6 oxygen atoms are there. So how many more we need to have? So 18 minus 6 is 12. How will you make 12? So you have to write 6 here. Fine. Simple balancing equation. Okay, done. So let us see the answer and then move ahead. Okay. Solution is balanced chemical equation is this, and then oxygen gas is evolved in the formation of glucose from carbon dioxide and water. Fine. Okay. Let's see the next question. Write the balanced chemical equation for the following. The liberation of nitrous oxide by the reaction between zinc and nitric acid. Other products are water and metallic nitrate. So let's start. Here we will learn a new method which is called partial equation method. Okay. So the method is called partial equation method. So what is that? I will tell you first. The liberation of nitrous oxide by the reaction between zinc and nitric acid. So what are the reactants? Reactants are zinc plus nitric acid, HNO3. What are the products? Products are nitrous oxide is formed first of all, then water and metallic nitrate. Metallic nitrate means here which metal is there? Zinc. So metallic nitrate is nothing but zinc nitrate plus liberation of nitrous oxide. What is the formula of nitrous oxide? N2O. This is the lowest possible oxide of nitrogen. Here the valency of nitrogen is 1. Okay. Now plus water. So this is the chemical reaction, reactants and products. Generally, if sulfuric acid and nitric acid are present, either nitric acid or sulfuric acid is present in a chemical reaction, then we adopt the partial equation method. Partial equation means what? We have to assume that the reaction is occurring in multi-steps. So we have to write step by step the reaction. So first what happens? Let's see. First is HNO3, that is nitric acid. it decomposes to form H2O, and you can see the product nitrous oxide is given. So this N2O plus nascent oxygen. This nascent oxygen oxidizes zinc to zinc oxide. Then that zinc oxide reacts with nitric acid to form zinc nitrate and water. So these are the different step reactions. So here first we will balance every partial reactions. Now you can see that in the left hand side one hydrogen is there, here 2 hydrogen, isn't it? Right hand side 2 hydrogen. So we have to write here at 2. Okay. Then nitrogen, sorry, it is nitrous oxide, so N2O. Okay. Now next step, you see nitrogen left hand side it is 2 and in the right hand side it is also 2. So nitrogen is already balanced. Let us look at oxygen atoms. So 2 3s are 6. Okay. So in water there is 1 oxygen atom. In nitrous oxide there is 1 oxygen atom. So 2 are over. So out of 6, 2 are there in water and nitrous oxide. So how many more are required? 4. So 4 atomic oxygen or nascent oxygen, we are writing here 4. Now the equation is balanced. Hydrogen, nitrogen and oxygen all are balanced. Next step, what will happen? So this is the first step. So write here first step. Now we will write second step. Now we will number the equations also. This is equation number 1. In the second step, what will happen? Zinc will react with nascent oxygen to form zinc oxide. It is assumed to take place in steps I told you. Okay. So here it is already balanced. Fine. Now third step we will write. In third step what happens? Let us see. In third step, this zinc oxide, which is the product in the second step, let us write this as equation 2. Zinc oxide plus nitric acid, it will react with nitric acid to form, it is an acid base reaction, very simple. ZnNO3 taken twice plus water, right? Now let us balance this third step. Left hand side 1 zinc atom, right hand side also 1 zinc atom. So this is balanced. Now let us see hydrogen. In left hand side 1 hydrogen is atom is there, and right hand side 2 hydrogen atoms are there. So let me write here first 2. Let us look at nitrogen then. So here there is no nitrogen. In nitric acid, now 2 molecules of nitric acid is there, so 2 nitrogen atom. Right hand side you see 2 nitrogen atom because ZnNO3 taken twice. Okay, so our zinc is balanced, our hydrogen is balanced, our nitrogen is balanced. Now let us look at oxygen atom. See here O3 and here O, 4 oxygen atoms, sorry. From zinc oxide there is 1 oxygen atom, and from nitric acid there are 2 nitric acid. So 3 2s are 6. So total 7 oxygen atoms are there. 1 plus 6 is equal to 7. Let us look at the right hand side. Right hand side, in zinc nitrate 3 2s are 6 oxygen atom, in water 1 oxygen atom. So here also it is 7. So now third equation is also balanced. Now let us erase the unnecessary things and then we will see the next step what we are going to do. Okay. Fine. So what we have to do now, the intermediate products, what you are not finding in the final reaction, so those intermediate products you have to see they should get cancelled. So how it can happen? Let us see. What are the intermediate product? See, look at the left hand side, the reaction Zn plus HNO3 gives rise to ZnNO3 taken twice plus N2O plus H2O. So these three are the products. Anything which is an intermediate product which is not there in the final product. So final products are these three: zinc nitrate, nitrous oxide and water, which are not there in the final products, but it is observed in the partial reaction that we must get cancelled. So let's see the first step. In that 4 nascent oxygen, that is not there, nascent oxygen is not there in the final product. So nascent oxygen we have to cancel. See, it is there in the product in the first equation and it is there in the reactant in the second equation. So the product obtained in the first equation is consumed as the reactant in the second equation. So these two must be same because it is totally consumed in the second step, which is formed in the first step. Okay. So here also we have to make it 4 nascent oxygen so that it can get cancelled. That means 4 nascent oxygen is forming in the first step, which is totally consumed in the second step. Okay. So if I make 4 nascent oxygen, then obviously I have to make 4 Zn, and which will give rise to 4 zinc oxide. Now you can see zinc oxide is also not there in the products. That means that is also an intermediate product. So the product obtained in equation 2, that is zinc oxide, is consumed in third step because that is the reactant in the third step. That means this also you have to get it cancelled because this is not there in the final product. Okay, so we have to zinc oxide, which is obtained in the second step, must be totally consumed in the third step. Okay. So here 4 ZNO, here also you have to have 4 ZNO. So that means I am multiplying the third reaction by 4. Okay. So here I am writing 4. So 4 ZNO will react with how many nitric acid molecule? 1 ZNO reacts with 2 nitric acid. So 4 ZNO will react with 8 nitric acid molecules. Okay. So let me change the color, then you can understand it better. There will be no confusion. First, let us remove this. Okay. So you carry out the reaction, you just multiply the third reaction by 4 and get the coefficients and obtain the coefficients of the third step. So I'll write here 4 and 4. Here earlier it was 2, remembered? So now it will be 4 2s are 8. Now here it is nothing is there, means 1, right? So 1 into 4 is, this is also 4. Now water is also 1, so I have to write here 4. Now what are you going to do? We will add all these 3 equations. Okay. First of all, the intermediate products will cancel. This is cancelled, this is cancelled with this. This is in the reactant side, this is in the product side. So already I have discussed, this is told the 4 oxygen nascent oxygen obtained in the first equation totally consumed in the second equation. Similarly, another intermediate product, 4 zinc oxide molecules will be totally consumed in the third step of the reaction. So these also will be cancelled. Now let us calculate the total of these 3 reactions. So let us start with nitric acid. Here 2 nitric acid is there, here 8 nitric acid is there. So total number of molecules of nitric acid, both are there in the reactant side, right? So it is 10 HNO3. You understood? Yes. Plus. So this is over, this is over. What all are there in the reactant sides? Only zinc. So 4 Zn. So we'll write here 4 Zn. Now we'll write the product side. So you see zinc nitrate, how many molecules? 4. So we'll write 4 ZnNO3 taken twice, plus you see nitrous oxide, only 1 molecule, so it is N2O, plus water, how many molecules? You see here 1 molecule in the first reaction, and in the third reaction 4 molecules. So 4 plus 1, it is 5 H2O. So now the reaction is balanced. Let us check once again. Okay. Left hand side 4 Zn, right hand side 4 Zn. So zinc is balanced. Now let us check the second element. Hydrogen, 10 hydrogen in the left hand side, and right hand side you see 5 2s are 10. So right hand side also 10 hydrogen. Let's look at nitrogen. 10 nitrogen in the left hand side, right hand side. In 4 molecules of zinc nitrate, in 1 molecule there are 2 nitrogen atoms, so 4 molecules, 4 2s are 8 nitrogen atom plus 2 here in nitrous oxide. So what is happening? 8 from zinc nitrate, 2 from nitrous oxide, giving rise to 10 nitrogen atoms. So nitrogen is also balanced. Now we have to see the most frequently occurring element, that is oxygen. So left hand side, in 1 molecule of nitrogen nitric acid there are 3 oxygen atoms, so in 10 molecules there are 30 oxygen atoms, right? So you have to see right hand side 30 they are there or not. Definitely it will be there. See, from in one zinc nitrate there are how many nitrogen atoms? How many oxygen atoms? 3 2s are 6. 6 oxygen atoms. So 4 zinc nitrates are there. So 4 zinc nitrates, 6 into 4, we are getting 24 oxygen atoms from zinc nitrate. From nitrous oxide we are getting 1, and from water we are getting 5. So 24 plus 1, 25 plus 5, total 30. So oxygen is also balanced. Done? Understood? Clear? Okay. Very good. You have worked out along with me? Fine. Now you want to note down. I am just giving you little time so that you can work out properly. I hope you are done with this. Okay, let us look at the solution. So solution is 4Zn plus 10 HNO3, 4Zn NO3 taken twice, N2O plus 5H2. Done? Okay. Let's move on to the next question. Write the balanced chemical equation for the following. Okay. So the liberation of hydrogen gas and the solid metallic nitrate due to the reaction between manganese and very dilute nitric acid. Let us work out. Okay. Then we will see the solution. So liberation of hydrogen gas, that means hydrogen gas is there in the product side. Okay. And reactant, what are the reactant? Reaction between manganese and very dilute nitric acid. What is the symbol of manganese? Mn. It is a metal. So monoatomic in nature, plus nitric acid, very dilute nitric acid, HNO3. So what will it give? Let's see what will it give. Okay. You write the product. One thing I would like to tell you, that manganese and magnesium are the two metals. These are the only two metals which can liberate hydrogen by the reaction with nitric acid. But nitric acid you have to take in cold and very dilute state. Now you write the product. I told you what will happen. So now you have to write the products. Okay. So get set ready with your products. Then I will help you in balancing. Balancing also you can do. So write the product, write the full chemical equation, and then balance the equation. Okay. So this will give manganese nitrate, MnNO3 taken twice plus hydrogen. How will you balance it? Very simple. This one thing you can see that in the left hand side, in the right hand side, hydrogen 2 are there. So left hand side I also have to make 2. So let me write here 2. Okay. So manganese is 1 in both the side. Hydrogen left hand side 2, right hand side 2 now. And then nitrogen left hand side we can see 2, right hand side also we can see 2. Now let's work on the oxygen. How many are there in the left hand side? 3 2s are 6. Right hand side 3 2s are 6. So the chemical equation is balanced. Let's see the solution and then we will see the next question. Solution is Mn plus 2HNO3 gives rise to MnNO3 taken twice plus hydrogen. Okay. Now we are going to discuss the most challenging questions based on chemical equation. Let's start. Okay. Let us look at the first question. So the first question is, X grams of a metal reacts with 32 grams of oxygen and the atomic weight of the metal is 0.5x. Calculate the valency of the metal. Okay. So let us see how will you do it. Here X grams of a metal reacts with 32 grams of oxygen. Let us look at this statement, this part of the statement. So we will write here. So 32 grams of oxygen reacts with how many grams of metal? X grams of metal. Why we have written that? Because I would like to calculate its equivalent mass. So if we can calculate the equivalent mass, atomic mass is already given, then we can easily calculate the valency. Okay. So in the definition of equivalent mass, what we have seen, the mass of an element which combines with 8 grams of oxygen, that is called the equivalent mass of that element. Okay. So here the element is this metal. So 32 grams of oxygen reacts with X grams of metal. So now we have to calculate for 8 grams of oxygen how many grams of metal it combines. This is 32. So it will be X divided by 32 into 8 grams, right? So this is equal to, we can write X by 4 or 0.25 X grams. Okay. So now what is this 0.25 X grams? It is the equivalent mass of the metal because it has combined with 8 grams of oxygen. So I can write that equivalent mass of the metal is equal to 0.25 X grams. This is, rather we should write gram equivalent mass. Gram equivalent mass, because we are writing unit gram. So gram equivalent mass of the metal is 0.25 X. Okay. And the atomic mass is given 0.5 X. Fine. So what is the gram atomic mass? GAM, gram atomic mass of the metal is equal to given, it is given, so 0.5 X, 0.5 X grams, right? So now we can easily calculate the valency. So let us write the relation again. Gram equivalent mass is equal to gram atomic mass divided by valency. Okay. So gram atomic mass is 0.5 X divided by valency is equal to gram equivalent mass, which is nothing but 0.25 X. Okay. So valency is equal to gram atomic mass divided by gram equivalent mass. So 0.5 X divided by 0.25 X is equal to 2. I hope you could understand the problem. Okay, let's see the solution. Everybody noted down? Okay, fine, good. So, solution. 32 grams of oxygen reacts with X grams of the metal. So 8 grams of oxygen reacts with X by 4 grams of the metal. That is nothing but 0.25 X, and it is nothing but gram equivalent mass of the metal. Atomic weight is given 0.5 X. So valency is equal to gram atomic mass divided by gram equivalent mass is equal to 2. Okay. Shall we move on to the next question? I hope everybody has copied. Okay. Next question is, a salt contains calcium and a negative radical containing nitrogen. If 3 molecules of the salt contains 18 atoms of oxygen, identify the acid and base from which it is produced. Okay. So let us work out. So for this, what we have to do? First we have to identify the formula of the compound. Then only we can formula of the salt here. Then we can identify which acid and which base from which it is produced. Fine. So the salt contains calcium as a positive radical, Ca plus 2. And what is the negative radical? Negative radical contains nitrogen, and 3 molecules of the salt contains 18 oxygen atom. That means in one molecule there should be 18 divided by 3, that is 6 oxygen atoms, right? So now let us look at the negative radicals containing nitrogen and oxygen. There is nitrite radical and nitrate radical. Both of them have valency -1, right? Now suppose if I write 3 molecules of calcium and nitrite, NO2 -1, then what will be the formula of the compound? Then it will be 3CaNO2 taken twice, right? So in that case, how many oxygen atom? Let us check. This is NO2 taken twice. So in one molecule there are 4 oxygen atoms. That in 3 molecules of calcium nitride there must be 4 3s are 12 oxygen atom. So this is not our negative radical then. So this is not our negative radical. We will work on the second one. Calcium nitrate, CaNO3 taken twice. So in one molecule there is 3 2s are 6 oxygen atoms. So 3 molecules there will be 3 6 are 18 oxygen atoms. So this is our salt. Fine. So required salt is CaNO3 taken twice. Name of it is calcium nitrate. So from which acid and which base it is produced, that we have to now identify. So it is very simple. Calcium, this is called, in a salt, the positive radical comes from a base and the negative radical comes from the acid. Okay. So then which base it is supposed to be? The base which contains calcium. So that is nothing but calcium hydroxide. Fine. And nitrate radical comes from nitric acid. So the acid is HNO3. Okay. So the base is calcium hydroxide and the acid is nitric acid. Let's see the solution and then we'll move on to the next question. So the solution is, see this side, right hand side you see the solution. The salt is calcium nitrate, the base is calcium hydroxide and the acid is nitric acid. Good? Okay. We'll move on to the next question. The equivalent mass of an element A is X. Okay. So then what is the rest of the part of the question? X grams of A reacts with Y grams of another element B. If the valency of B in the product is 2, what is the atomic mass of B? What I told you today's class, that one equivalent mass of an element always reacts with one equivalent mass of other element. Okay. So based on that we will solve that problem, solve this problem. The equivalent mass of an element is A is X. So element A, its equivalent mass is X, right? Now it is said that X grams of A reacts with Y grams of B, right? So since X grams of A is combining with Y grams of B, it is very obvious that element B, its equivalent mass is Y, right? So equivalent mass of A is X and the equivalent mass of Y is B. So this we know. Now if the valency of B in the product is 2, what is the atomic mass of B? So how will you calculate? Again the same formula, equivalent mass is equal to atomic mass by valency. So how will you, now here you know the equivalent mass, you know the valency is 2. So what will be the atomic mass? Atomic mass of which element? Of B is equal to equivalent mass into valency, right? So equivalent mass of B is Y, valency is 2, so it is 2Y. Done? Understood? So atomic mass of B is 2Y. Let's see the solution and then we'll move on to the next question. Solution is equivalent mass of B is Y. So equivalent, since the valency of B is 2, so the atomic mass is 2Y, right? The atomic mass is 2Y. 2y. Equivalent mass of B is y, valency is 2, so atomic mass is 2y. Okay, let's move on to the next question. Find the number of phosphine molecules formed when 5 molecules of calcium phosphide reacts with water. Okay, so let's see. Select line is another product. One product is phosphine, another product is select line. So first we have to write the reaction, then we have to balance it, then we have to do the necessary calculation. Let's see. Let's start. So what are the products here? Calcium phosphide Ca3P2 reacts with water to form select lime calcium hydroxide plus phosphine. Done? Okay. Reaction is ready. Now what you have to do? You have to balance. Look at this. Calcium, 3 atoms are there in the left hand side. Definitely have to write here 3 to make left hand side and right hand side equal calcium atoms. Fine. Next, look at the phosphorus atom. P2. Here left hand side it is 2 phosphorus atom, right hand side 1. So definitely I have to write here 2. Fine. Okay. Now next element, hydrogen. Here left hand side it is 2 hydrogen atom, right hand side how many? See, 2 occurrences, 2 places hydrogens are there. From in one molecule of calcium hydroxide, 2 hydrogen atoms. So 3 molecules of calcium hydroxide, there will be 6 hydrogen atoms. 6 hydrogen atoms. In phosphine, in one molecule there are 3, so 2 molecules there are 3 to the 6. So 6 plus 6 is equal to 12 hydrogen atoms. Fine. So I have to make it 12 left hand side also. How will I do it 12? If I write 6, then 6 2s are 12. Done. So our calcium, phosphorus, hydrogen atoms are balanced. Now oxygen. Left hand side how many oxygen atoms are there? 6. Right hand side you check. In one calcium hydroxide there are 2 oxygen atoms. So 3 calcium hydroxide there are 3 to the 6 oxygen atoms. Okay. So you could understand. See, left hand side 6 oxygen atoms, right hand side also 6 oxygen atoms. Clear? Okay. So our equation is balanced. Now what you have to do? You have to find out the number of phosphine molecules formed when 5 molecules of Ca3P2 reacts with water. Okay. You can see calcium phosphide. What is its coefficient? Its coefficient, no, nothing is written, means it's 1. So 1 molecule of calcium phosphide gives rise to 2 molecules of phosphine. Then if 5 molecules of calcium phosphide, okay, let us write it, then you will understand better. 1 molecule of Ca3P2, 1 second, I'll just erase that side so that you can understand easily. So you don't stop your writing, you can carry out because everything is explained and you can do it now. 1 molecule of calcium phosphide gives 2 molecules of phosphine, that is pH3. Okay. Then 5 molecules of calcium phosphide if we take, then the number of phosphine molecules will be 5 into 2, 10 molecules of phosphine. Understood? Clear? Okay. So let's see the solution and then we'll move on to the next question. Okay. Solution, you can see the balanced chemical equation and the 10 molecules of phosphine. Clear? Okay. Good. So the next question is, the relative molecular mass of an element is XAMe. Okay. So what do you mean by relative molecular mass? Okay, let us recollect that. So relative molecular mass of an element is how many times the one molecule of that element is heavier than 1/12 of carbon 12 isotope. Since it is a comparison, so it is written relative. Okay, understood? So once again I am repeating. So relative molecular mass of an element is the number of times the molecule of that element is heavier than 1/12 of carbon 12 isotope. Fine? Okay. Now it is given that if its atomicity is 3, find out the mass of 5 atoms of element in grams. Okay. So let's start. So we know the molecular mass of the element and its atomicity. So let us write RAM, relative molecular mass. So RMM, relative molecular mass, is equal to XAMU. Now its atomicity is 3. What does it indicate? In one molecule there are 3 atoms. Then what should be the relative atomic mass of that element? RAM, relative atomic mass of the element will be x by 3 because its atomicity is 3. So it is x by 3 AMU. Fine. Then what is the mass of 5 atoms of this element in grams? Okay. So what is the mass of 5 atoms of element in AMU? First let us see. So 5 atoms, the mass of 5 atoms of the element, 5 atoms of the element is equal to x by 3 into 5. What is the unit? I told 5 atoms, so it is AMU. Now we have to convert it into grams. You have studied in the basics. Again I will tell you, try to recollect what is the relation between AMU and grams. 1 AMU is equal to 1.6 into 10 power minus 24 grams. Now I will use this. So the mass of 5 atoms of the element, 5 atoms of the element in grams is how much? X by 3 into 5 into 1.6 into 10 power minus 24 grams. Understood? Do the calculation. Carry out the calculation. I am giving you a little pause and then we'll move on to the solution. Okay? Ready with your answer? Let's look at the solution. Relative atomic mass is x by 3. So x by 3 into its mass. If it is in AMU, we are converting here immediately after finding out the relative atomic mass. So x by 3 into 1.6 into 10 power minus 24. Now 5 atoms means you have to multiply the whole thing by 5. Okay. So x by 3 into 5 into 1.6 into 10 power minus 24 grams, that is equal to 2.66x into 10 power minus 24 grams. Understood? Okay, good. So we'll move on to the next question. Let's look at the next question. So what is the next question? Next question is, one molecule of calcium phosphate reacts with silica and coke and gives rise to calcium silicate, phosphorus and carbon monoxide, right? Calculate the loss in weight due to the formation of the gas. So what is the first step? We know the reactants and all the products. We will write the chemical equation, then we will balance it, then we will find out the loss of weight due to the formation of the gas. Okay, let's start. So you people should start writing because you know all the reactants and products. What you have to write? Only you have to write it present it in the form of chemical equation, right? So chemical equation, for writing chemical equation, what you need to know? You need to know the formula of the compounds or elements participating in the reaction and the formula of the products also. So let's start. So what are our reactants? Our reactants are calcium phosphate, silica and coke. So calcium phosphate, what is the formula? Ca3PO4 taken twice. Already we have done it, worked it out in the exercise, in this exercise. Calcium phosphate plus silica is SiO2 plus coke is C. Now it gives rise to calcium silicate, CaSiO3, phosphorus is P4 and carbon monoxide is CO. I wrote 4, why? You know, already discussed in this class, that is, it is tetraatomic. Phosphorus is tetraatomic, its atomicity is 4. Fine, now we will balance it. Start with calcium. Okay, you carry on. I am waiting for you. You first balance and then you will tally it with me. Okay. So start with calcium. How many calcium atoms are there in the left hand side? In the left hand side there are 3 calcium atoms, right? So right hand side also you have to make it 3. So this is 3 calcium atom. Okay. Now next element, phosphorus, P. Left hand side how many phosphorus atoms are there? 2. Right hand side how many phosphorus atoms are there? 4. So what I have to do? Left hand side also have to make it 4. So I have to write a coefficient here 2, so that the left hand side phosphorus atoms becomes 4. Now the moment I am writing this, my calcium got disturbed. Now what is the number of calcium atoms in the left hand side? 3 2s are 6. Good. So we have to make the right hand side also, you have to make the change. So let us see. So calcium atoms, if I have to make 6 here, then what we have to do? I have to remove 3 and then write 6. Okay. So this will be now 6, not 3. Fine. Okay. So calcium is balanced and phosphorus is also balanced. Okay. Oxygen will do it at the end, because the frequency of occurrence of oxygen is maximum here. You can look at here left hand side in 2 compounds like calcium phosphate and silica. Both the places oxygen is there, and in the right hand side also it is like that. Calcium silicate, carbon monoxide, both the places oxygens are there. So its frequency of occurrence is more. So we'll do it at the end. Okay. So next compound we'll look at silica. Silicon. In silica, silicon is there. In the left hand side only 1 silicon atom, but in the right hand side 6 silicon atoms are there. So I will write here 6. So 6 silicon atoms in both the sides. So silicon is balanced. Okay. Fine. Now carbon. Both the sides you can see 1 carbon atom is there. As of now carbon is balanced. Fine. Now we will work on oxygen atom. Left hand side calcium phosphate, how many oxygen atoms it is giving? In 1 molecule of calcium phosphate there are 4 2s are 8 oxygen atoms. So 2 molecules there will be 16 oxygen atoms. Look at the silica, another compound where oxygen atoms are there. 6 silica molecules gives 12 oxygen atoms. So 16 plus 12, total number of oxygen atoms is 28 oxygen atoms, right? 28 oxygen atoms. Let us work out in the right hand side. Calcium silicate, how many oxygen atoms it is providing? 6 3s are 18. 1 molecule of calcium silicate has 3 oxygen atoms. So 6 molecules of calcium silicate will have 18 oxygen atoms. So here we are getting 18 oxygen atoms. So how much is the shortfall? Right hand side 18 oxygen atoms and left hand side 28 oxygen atoms. So difference is 10, right? So let me put here 10. Okay. Then my oxygen is balanced. So right hand side, let us check. 18 oxygen atoms are coming from calcium silicate and 10 from carbon monoxide. So 18 plus 10 is 28. Both the side 28. Done. But now number of carbon atoms in the right hand side has become 10. So left hand side also you have to make it 10. So we have to write here 10 carbon atom, right? So now the equation is balanced because all the elements are balanced. Now what is the question? Let us see. Calculate the loss in weight due to the formation of the gas. Now look at the product. So which one is in the gaseous state in the right hand side, that is in the product side? Can you tell me? Is calcium silicate gas? No, it is a solid. Phosphorus is also a solid. So which one is the gas? The gas is the carbon monoxide. So this is gas. So you can see from the balanced reaction that 2 molecules of calcium phosphate gives rise to 10 molecules of carbon monoxide. So but here the question is, 1 molecule of calcium phosphate reacts with silica and coke. 1 molecule of calcium phosphate. So 2 molecules of Ca3PO4 taken twice gives rise to 10 molecules of CO. Here also it is molecules. Okay. So 1 molecule of calcium phosphate, how many carbon monoxide molecules will it give? Very simple, 5 molecules, half. So 5 molecules of carbon monoxide. Now what you have to calculate? You have to calculate the mass of 5 molecules of carbon monoxide. So how will you calculate? For that we have to know relative molecular mass of carbon monoxide. RMM of CO is 28 AMU or unified mass. That means the mass of 1 molecule of carbon monoxide is 28 AMU or unified mass. So what will be the mass of 5 molecules of carbon monoxide? Because you have to calculate the mass of 5 molecules of carbon monoxide. From the balanced chemical equation we have come to know that. So what is the mass of 5 molecules of carbon monoxide in AMU unit? It is 5 into 28 AMU or U. Now it is in AMU unit, but you have to calculate it in grams. So how will you calculate the relation between AMU and grams? We have done it, already worked out in the previous problems. We have seen 1 AMU is equal to 1.6 into 10 power minus 24 grams. So 5 into 28 AMU is equal to, if I convert it into gram, is equal to 28, 5 into 28 into 1.6 into 10 power minus 24 grams. So this is our answer. Okay, understood? Let us look at the solution. So the balanced chemical equation you have seen, 1 molecule of calcium phosphate produces 5 molecules of carbon monoxide. So loss in weight is because of these 5 molecules of carbon monoxide gas. What is its mass? 5 into 28 into 1.6 into 10 power minus 24, that is equal to 224 into 10 power minus 24 grams. Okay, I hope you have enjoyed these problems. Okay, very good. Prepare for the basics properly every time and then you attend the exercise session. Good. Thank you.